right, let's take a look at the first 3 problems on this surface area exploration worksheet. Apply your surface area formulae to solve the following problems. Let's take a look at number 1. Write a formula for the surface area of a cube with a side length of s units. Okay, so I'm going to suggest let's draw in a picture for this. Always a sound strategy when you're working these geometric problems. Okay, so you draw a square, you draw another square congruent to it, just offset it a little bit, dash some of the hidden lines. Look at this. Very convincing. Maybe I add a little bit of shading to this. Okay, so, and maybe one of these colors. It's really coming together. Very convincing. I don't think you need 3D glasses for that. It looks like this is probably popping right out at you on the screen. Anyway, so the side length is supposed to be what? S, little s. Little s, little s, little s. And we want to write a formula for the surface area. Well, a cube is an example of a prism. So I'm going to use the formula for the surface area of a prism. It's a capital S. This is going to be totally confusing. A big S and a little s. Anyway, that's supposed to be the perimeter of the base, and then we're going to multiply that times the height. Well, what shape is the base of a cube? It's a square. And its formula here, of course, is 4 times s. There's 4 of those s's. So I'm going to take that p out. Actually, let me change colors to make this look real nice. All right. I'm going to take that p out, and I'm going to substitute in a 4s in its place. Right? All right. So I would have a 4s, and I'd multiply it by, let's say, the height. And well, what's the height of this thing? Well, the height here is also s, so I'm going to multiply that times another s. S times s is s squared, so this would be equal to 4s squared. Well, doesn't that make sense? The lateral surface area, that's just composed of 4 squares, and that's what I got. I got 4 times s squared. Each one of those is s squared. Each one is the area of the square. All right, well, that makes sense. What about the total surface area? When it says surface area like this one does, it usually means total surface area. So we forgot a piece right here. What we forgot was the 2 bases. I need to add in some bases right here. Not just one of them. How about 2 bases? All right, so I'm going to have to move some of this stuff over. So maybe put that here. Add in 2 bases. Might put a plus sign. Yeah, that's good. So my 2 bases, each base is a square. So just go s times s for its area. And if I have 4s squared plus 2 more s squared, I should get 6s squared. Well, there you go. Man, I think that was probably a bit of overkill. As far as finding the surface area formula for a cube, well, let's just examine this formula as it is. It's 6 times s squared. S squared is the area of one of those square faces. And how many sides on a cube do you have? You got 6 of them. That should have made sense. We could have probably done that in just a single step. Anyway, let's take a look at number 2. Referring to question 1, solve the cube surface area formula for s. So it's this one that we just developed. We're going to solve it for s. That means get s by itself. Isolate it. I'm going to write down my big S is equal to 6 times little s. You can see the difference, right? Squared. And we're going to solve that thing for s. So to solve it for s, we need to first divide over the 6. All right, and so I would have s over 6 is equal to little s squared. So I have s squared, but I want s. How do I get rid of the square? I do its inverse, which is, of course, taking the square root of both sides. Yeah. Now, any number would have 2 square roots, as we've said before, but we only want the positive one here because we're talking about lengths and areas and whatever. So our side length of our square has got to be a positive number. We only want the positive square root of big S. I don't think I can see the difference there. Big S over 6. We got it. I wonder why we had to do that. I wonder if we're going to use it again in the next example. Let's see. Number 3, write a formula for the surface area of a cube in terms of P, the perimeter of one of its faces. All right. So on a question like this, we want to take it a step at a time. We are writing a formula for what? For the surface area of a cube. So that's what I'm going to start with. The surface area of a cube we already wrote. We derived it because it was impossible to think of, 6 faces and each one of them is s squared. We actually went through the process of breaking it down with p times h plus 2, whatever. Okay, so it's this formula. Okay, so there's the first part. Now, right now, the formula is in terms of s. I need to know what the little side length is, plug it in, and I can find the surface area. This is asking us to put it now in terms of p. So instead of there being an s there, we need a p in there. And we know that the perimeter of a square is supposed to be 4 times s. Now what we've just developed here is a system of equations. I'm going to use a substitution to replace the s that's in here with an equivalent expression containing a p. To do that, I got to get s by itself in this perimeter equation. Easy to do. Just divide by 4. Divide by 4. So my s should be equal to p over 4. I'm going to take p over 4 and just plug it in for my s. That's right there. Substitution. And so here now is my new formula for the surface area in terms of the perimeter of the base. It's 6 times p over 4. And then you would square it. And you can leave it like that if you want to, but I think we can do some algebra and clean this thing up just a little bit. I need to square both pieces inside of the parentheses here, so p gets squared and the 4 gets squared. And then 4 squared is 16. And then 6 and 16 have a common factor of 2. Divide that by 2 and we'd get 8. Divide this one by 2 and we'd get 3. So finally, here's my final version of this formula. Big S is equal to, no, I still have a 3, don't forget. A 3 times my perimeter squared, and then divide that whole thing by 8. Weird. Probably not a formula you've ever seen before, but it would work if you had the perimeter of your square base. You'd square it, multiply by 3, divide it by 8, and there you go.